Right. So today I'm going to be introducing you to series circuits. So what that really means is that there's going to be a circuit with multiple resistors. Okay. So the simple circuit was just a battery, one resistor, and that was it. So this one has two. It could have 2, 3, 4, 5, whatever. So and a series circuit has them aligned all in one path. So the current goes through the first resistor, goes to the second, goes to the third, and then back to the battery. So let's dive in and see how this actually works. So over here, I actually have 3 resistors. Okay, there are 3 different ratings. So this one right here is an 11 ohm resistor. So I'm going to put this down as 11 ohms. This one right here is a 13 ohm resistor. So 13 ohms. And the last one is 24 ohms. Okay, so how much current is going to be flowing through this? Well, first, the battery is a 6-volt battery. So I'm just going to put 6 volts. Okay, so we need to know how much the total resistance is going to be in order to figure out the current. And in the case of a series circuit, it's actually really easy. So I'm going to put RT for the total resistance. It's just the first resistor plus the second resistor plus the third resistor, and if there's more resistors, it goes on. So in this case, the total resistance is 11 plus 13 plus 24. And if you're wondering what that is, add them all together and you get a total resistance of 48 ohms. And now it's just like our regular simple circuit. Okay, we have the formula Ohm's law, which is V is equal to I times R. Voltage, we know, is 6 volts. The current, we don't know yet. That's what we're trying to figure out. So I'm going to leave that as I. And the resistance, we just calculated to be 48. Simple math, we just divide each side by 48. 48's cancel. And 6 divided by 48, if you were to simplify that fraction, it would just be 1/8. So the current is 1/8 of an amp. In decimal form, it would be 0.125 amps. And if we were looking to put that into milliamps, it would be 125 milliamps. All those are the same. So let's see how accurate our calculations are compared to our actual circuit. So it's set to the current. I'm going to hook this up to the battery. Then I'm going to hook this up to the resistors. And we get about 123. Okay, so actually very close. The only real losses would be in the wires, okay, or possibly at these different connections. But you see the formulas do work. Okay, so disconnect that. So there's actually some worksheets involved with this. So I'm going to go through a couple of them with you. So for number 1, we're given a battery of 24 volts and we're given 3 resistors, 3, 4, and 5. And we have to find the current. So first thing we have to do is find the total resistance, which is the first resistor plus the second resistor plus the third resistor. And we know that the first resistor is 3, the second resistor is 4, and the third resistor is 5. And we come up with a total resistance of 12 ohms. And then just go back to Ohm's law. V is equal to I times R. Voltage is 24. Current we don't know yet, so that stays as I. And the resistance we just found is 12. So divide both sides by 12. 12's cancel. 24 divided by 12 is just 2. So there would be 2 amps flowing through that circuit. Okay, so 2 and 3 are kind of the same as that. Okay. On the next sheet, it gets a little bit more complicated. So we actually know the current, but we don't know one of the resistors. So in this case, we actually have to find the total resistance using Ohm's law first. So since we know the voltage and we know the current, we'll be able to figure out the resistance. Voltage is 24. Current, in this case, is 2. We don't know R. Divide both sides by 2. We find that the total resistance is going to be 12. Now we have to figure out what that resistor has to be. So the total resistance has to be equal to the first resistor plus the second resistor plus the third resistor. The total resistance we found was 12. First resistor is 2. Second resistor is 7. We don't know the third resistor. So this just becomes 2 plus 7, 9. And it's pretty obvious, minus 9, that the third resistor has to be 3 ohms in order for the calculations to work out. So I want you to try to do the series circuit worksheet, and there will be a quiz to go along with this at the end of the week. And remember, if you have any questions, you can email me. You can write it in a private comment on the assignment. You can go to the Google Doc that's included with all these materials and ask a question there. And remember, if you don't remember something, go back, watch the video. It's that simple.